Hello, and today we are going to work on section 3.5, and that's working with sets. We're going to do a lot of stuff today with sets of information. So you're going to have to take a lot of notes, and I want you to be prepared to stop and rewind, because some of this might be a little new and confusing. So let's get started. So from before, we learned in chapter 1, I think it was section 1.3, a set is a distinct collection of elements. Now, math, typically those elements are numbers. We usually see sets as a collection of numbers. A subset contains elements from the original set. So if that helps, remember, if I had the set of numbers, let's say 4, 8, 12, and 16. Let's say that's my set. My subset would be, let's say, 4 and 12. That would be a subset, because everything in the subset is contained in the original set. And so if you look up here, this is what we call roster form. So roster form lists elements from a set with brackets or braces. These symbols right here. For example, the set containing the number 1 and 2 would look like, in brackets, 1, 2. This is the form we have most commonly seen in the past. Okay, moving on. Set builder notation. This is where it might get a little confusing, so pay attention. So set builder notation is another way to write sets. It describes the properties an element must have to be included in a set. For example, if we have the set in roster form, 2, 4, 6, 8, and continues on, so 10, 12, 14, 16, 18. In set builder notation, we would write it as the set of all real numbers x such that x is a multiple of 2. So, right here is an example of set builder notation. Right here. And notice it still has the brackets, but unlike roster form, which is over here, where I'm circling with the pen, 2, 4, 6, 8, this one just lists all the elements that are contained in the set. In set builder notation, it's giving the directions or the properties that allow an element to belong to a set. So this one doesn't list all the elements, but it tells what qualities the numbers must have to belong to this set. And for this one, it's x must be a multiple of 2. So the set of all real numbers, x, such that x is a multiple of 2. So let's try this one together. It says, write T is the set of natural numbers that are less than 6 in roster form and set builder form. So since my set is called T, I'm going to write roster form right here. I say T equals, I'm going to put the braces, and then remember, it's the set of all natural numbers that are less than 6. You have to think, what are natural numbers? And if you remember from chapter 1, natural numbers are the positive counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this question is saying the set of natural numbers that are less than 6. So, knowing that, 1, 2, 3, 4, and 5. It's not less than or equal to, so we can't include 6. And 0 is not a natural number, so it's not included. Well, if I went to set builder form, my set is called T. Okay, T is not my variable, T is my set. It's the name of my set. And so in set builder form, I know that I'm just going to use the variable x. So it's all natural numbers x such that, or all real, no, sorry, this is all real numbers x such that x is a natural number x is a natural number and x is less than 6. In set notation, in a set builder notation, if there's multiple qualities that make something part of a set, you separate it with the comma. So I know in this set it's the set of natural numbers, and they have to be less than 6. So I wrote x is natural number and x is less than 6. So the way this reads right here is set T is the set of all real numbers x such that x is a natural number and x is less than 6. Try this one. N is the set of even natural numbers that are less than 12, that are less than or equal to 12. Write it in roster form and set builder notation. So since my set is called set N, I need to write it in roster form. So it's a set of even natural numbers that are less than or equal to 12. So since it's natural numbers, I don't include 0, so I start with 2, 4, 6, 8, 10, and 12. 12 is included because it's less than or equal to. Now in set builder form, I'm going to put this as roster. I'm going to put it in set builder. N is the set of all real numbers x such that x is an even natural number and is less than or equal to 12. So now let's look at this question. It says multiple choice. In set builder notation, how do you write the solutions? Notice solutions. There's more than one. Solutions of the inequality negative 5x plus 7 is less than or equal to 17. So it gives me the options x is greater than or equal to negative 2, the set of all real numbers x such that x is greater than or equal to negative 2, negative 2, negative 1, 0, 1, 2, or the set of real numbers x such that x is less than or equal to negative 2. So let's look at this together. So the first thing I need to do is I'm going to subtract 7 from both sides. I need to solve this just like I would solve a multi-step inequality. So I'm going to subtract 7 from both sides, and I get 17 minus 7, that equals 10. And so if I simplify, those cancel out, and I'm left with negative 5x. Negative 5x is less than or equal to 10. Next, I'm going to divide both sides by negative 5. Now remember, when you divide by negative, you have to flip the inequality symbol. So now it becomes greater than or equal to. So the answer is x is greater than or equal to negative 2. So therefore, I can eliminate C and D. So it's either going to be A or B. But then the question asks, in set builder notation. So therefore, this is not in set builder notation, so it can't be A. So my answer has to be letter B. In set builder notation, how do you write the solutions of 9 minus 4n are greater than 21? Give it a shot. If it helps, look at the past slide and look at the notes that you took and use that information to help you set up this one. So first things first, I need to solve for my variable n. So I'm going to subtract 9 from both sides. And I get negative 4n is greater than 21 minus 9, 12. Then I'm going to divide both sides by -4. Now, because I'm dividing by negative, my sign is going to flip. And my variable is now n, and so I have to do 12 divided by -4, which is -3. So since n is less than -3, to write this in set builder notation, put the bracket, there we go, put the bracket, and since my variable is n, I'm going to use n. We've been using x the entire time in the past, but that's because my variable is x. Or I got to choose my variable. In this problem, my variable is n, so I have to use n. So the set of all real numbers n, such that n is less than -3. And that is the answer. So you know that a set A is a subset of set B. So right now we're given two different sets. There's a set A and there's a set B. We know that set A is a subset of set B if each element of A is also an element of B. So if everything in set A is included in set B, then I can say A is a subset of B. So for example, B is -2, -1, 0, 1, 2, and 3, and A is -1, 0, and 2. Since all the elements in set A, -1, 0, and 2, are contained in set B over here. Here's -1, here's 0, here's 2. I know that A is a subset of B, and so I can write this as a relationship as A is a subset of B, or A is a subset of B. That's the notation right there. The sideways U with a line under it. Now, there's never anything that belongs to the set after you're given the properties. We call it an empty set or a null set. It's the set that contains no elements. The empty set is a subset of every single set. So we use the 0 with a line through it, or the brackets with nothing in between there to represent empty set. Very important though, make sure you have this written down. The empty set is a subset of every set. So no matter what your set of numbers are, whether it's B up here or it's A, I can say that the empty set is a subset of both B and A, because every set, the empty set is a subset of every set. So list all the subsets of the set 2, 4, and 6. Alright, so all the subsets of the set 2, 4, and 6. So let's start with 0 elements. So let's start with the empty set. Alright, now let's start with all the single element sets. So there's 2. And when you're listing it, you have to put the brackets, because remember, the brackets show it's a set. There's 4, 6. Even though there's one element, it's still a subset of the original set, because all the elements in the subset are contained in the original set. Now let's list all the possible subsets with 2 elements. There's 2 and 4. There's 2 and 6. And then there's 4 and 6. And then finally, the set itself, 2, 4, and 6. And there you go. That's all the subsets. Try this one. List all the subsets of the set F. So there's the empty set. There's A. There's B. And finally, there's A and B. And that's all the possible subsets. All right. Read this question to yourself and see if you can understand what it's asking. And then I'm going to read it in 1 second. So this says, let A equal the set of all real numbers x such that x is less than negative 2, and B is the set of all real numbers such that x is less than or equal to 0. Is A subset of B? So what we have to do is we have to think. A is the set of all real numbers that are less than negative 2, and B is the set of all real numbers that are less than or equal to 0. So if I start listing some of these out, it's negative 2, oops, negative 2, negative 3, negative 4, etc. I don't know why this is acting screwy. And then let's look at the set of B. So that's and then all the other set parts of set B are 0, 1, negative 1, negative 2. All right, let's do it again. Negative 3. Etc. So all the elements of B, all the elements of A are going to be contained in B, so the answer is yes. Because all the elements of A are negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Sorry, negative 2 is not included in this. That's why I scratched it out, because it's less than negative 2. Set B contains 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So everything from set A is contained in set B, so the answer is yes, it is a subset. I'm working with sets. You call the largest set the universal set. So that's the set of everything that you're talking about. And then the complement of a set are all the elements in the universal set that are not in the given set. It's a little confusing, and I'll show you what that means. So here's something that you need to write down that's important. It says, if we have a set, and we call that set A, so the set is called A, then the complement is written as A prime. That apostrophe right there is A prime. Okay? So if we have a set called A, then the complement is the set called A prime. So let's look here at this example. So in the Venn diagram below, U is going to represent the universal set. It's the whole thing. It says, notice that A is a subset of U, where A is the circle part. So set A is the circle inside the whole entire universal set. Set A is shaded. That's what's shaded right there. Well, everything that doesn't belong to set A is going to be called A prime. That's contained in the entire universal set. It's contained in everything. But A prime is everything that doesn't belong in A. So A plus A prime, if it helps you think about it, make up the set of the universal. So once again, everything in set A, is everything in the complements of A, makes up the universal set. So let's look at this example. It says, universal set U contains the chess pieces, the king, queen, bishop, knight, rook, and pawn. Those are all the possible chess pieces in traditional chess. And set A is going to be the set of chess pieces that move side to side. So not diagonally, not up and down, it moves from left to right. What is the complement of set A? So if my universal set is all of the pieces, A, set A, is going to be all the pieces that move side to side. So let's list them, that pieces that move side to side. Well, that's the king. The king moves from left to right, moves side to side. So does the queen. The bishop does not, because it only moves in diagonals. Nor does the knight. The knight kind of moves in an L shape, so it can't be the knight either. The knight moves in L shape, bishop moves in diagonals. The rook, the castle, can move from left to right. And the pawn can only move forward. It can't move in any other direction. So therefore, it is not a piece that moves side to side. So the complements of set A, remember we write it as A prime, are all the pieces that belong to the universal that are not in our given set A. So the king is out, the queen is out, and the rook is out, so I'm left with the bishop, the knight, and the pawn. And if it helps, let's make a Venn diagram of it. We'll call this whole entire thing U, because that's our chess pieces. Set A is going to be labeled as all the pieces that can move side to side. And so that's going to be king, queen, and the rook. I'm going to label them with the first letter. King, queen, rook. Right, it's KI for king. And then everything that's not is the bishop, the knight, and the pawn. Okay, so this is chess pieces. Excellent. All right. Try this one on your own. The universal set is the months of the year. Set A is the months with exactly 31 days. What is the complement of set A? The complement is A prime. Write it in roster form. So all the months that don't have 31 days, A prime. So it's February, April, June, September, and November. Good. All right, I hope this was informative. I hope you took some good notes. Don't forget to take the Kia quiz at the end of this video, and I hope you have a wonderful rest of the day. See you later.